Okay, so this video should help you with some of the problems on the prep quiz on 1.8 and also help you to understand the relationship between position, velocity, and acceleration of an object. This is really kind of cool application of calculus that hopefully you'll use a lot in the future. Basically, if you have a function such as, I know I keep using this, s of t is equal to 16t squared minus 32t. And you want to find this is the position of the function. If you want to find the instantaneous velocity at a certain point in time of the object somewhere at some place along this function, you take the derivative of s of t. So you say s prime of t is going to give you 32 t minus 32. This is going to give you the velocity of the object at that instantaneous point in time. So this s prime of t is the same thing as saying v of t. So that's what they're talking about right here. Then, if you want to find at a certain velocity at a certain point in time, if you take the derivative of the velocity function, so if you say s double prime of t, or you can say v single prime of t, you're going to get the acceleration. So in this case, the derivative of the velocity function is going to be 32. So this is the acceleration at that point in time, which is, we could call that a of t. So one thing that's pretty neat about derivatives is if you have a position function, okay, so the derivative of the position function is going to be, so we've got s of t, then we've got the derivative s prime of t is going to be v of t. That's the velocity. Then v prime of t is going to be a of t, which is the acceleration. Okay, so to put this to use, let's try working a, whoops. Okay, so here's a problem that you may see on your prep quiz. It says an object moving in a straight line travels s of t kilometers in t hours, where s of t equals 9t squared plus t. A says, what is the object's velocity when t equals 5? So because we're finding the velocity, we need to see, so v of t is going to be the same thing as s prime of t. So let's figure out what the derivative of s of t is. S prime of t is going to be what? 18t plus 1, right? So if we say v of 5, that's just going to be 18 times 5 plus 1, which is 91 kilometers per hour. Okay, so if we do B says how far has the object traveled in 5 hours? So since we're talking about the distance, we're going to just use the function s of t. We're going to find s of 5, which is going to be 9 times 5 squared plus 5, which is 230 kilometers. And then lastly, for C, it says, when is the object traveling at a rate of 5 kilometers per hour? So if we know the rate is 5 kilometers per hour, we know that's the velocity. 5 kilometers per hour is our velocity. So we can use the velocity function, v of t equals 18t plus 1 that we found in A, but we know that the velocity is going to be 5, so we've set 5 equal to 18t plus 1. Solve for t, and so we get what? 4 equals 18t, divide both sides by 18, and we get t equals, what is that? 2/9 hours. So that tells us when the object is traveling at a rate of 5 kilometers per hour. Okay, so that's one type of problem. This next type of problem is a similar idea. If we have a toy rocket being fired straight up into the air, its height is s of t right here. So that's, again, our position function after t seconds. So we're going to answer a couple of questions. A says, what is the rocket's initial velocity when t equals 0? So, since we're asking for velocity, we've got to find the velocity is going to be s prime, the derivative of the position function, which is going to be, in this case, what? 128 minus 32t. So to find the initial velocity when t equals 0, we're now going to plug in v of 0, which is going to be 128 minus 32 times 0, which gives us 128. So initially, the toy rocket is going 128 feet per second. Okay, so now let's look at B. B says, what is the velocity after 2 seconds? So again, this is velocity, so we're going to use our same velocity function. V of t is the same thing as s prime of t, which is 128 minus 32t. So we're going to just plug 2 in. So v of 2 is going to be 128 minus 32 times 2, which is 64 feet per second. Okay, so C says, what is the acceleration when t equals 5? Acceleration is our key word. Remember, acceleration is the derivative of velocity. So we're going to say A of t is going to be the same thing as v prime of t. So we have to take the derivative of the velocity function, which was the derivative of this. So we're going to say that's going to be negative 32, right? So the acceleration really at any point in time, since there's no variable here, the acceleration A of t, or I'm sorry, A of 5 is just going to be negative 32 feet per second squared. Then D, let's find a different color here, D, is going to be, at what time will the rocket hit the ground? So if you think about it, the rocket hitting the ground is referring to position. So we have to go back to our position function, which is the original function. And when the rocket hits the ground, the height is going to be 0, right? So we're just going to find s of 0. So we plug in 128 times 0 minus 16. Whoops, no, stop. When the height is 0, our s, not paying attention here, that means s of t has to be 0. So we're going to set this function equal to 0. We're going to say 128t minus 16t squared. Set that equal to 0 and see what time gives us a height of 0. So if we factor a t out here, actually we could factor out an 8t, or no, we could factor out a 16t. If we factor out a 16t, we're going to be left over with 8 minus t equals 0. So we set each term equal to 0. So 16t equals 0 and 8 minus t equals 0. So we get t is equal to 0. Also, t is equal to 8. So if you think about it, if the rocket is shooting up in the air and then coming back down, obviously when it leaves the ground, it's going to be at it's going to leave the ground at time t equals 0. So the t equals 0 here represents when it leaves the ground. So it's going to smash back into the ground at the other time at 8 seconds after takeoff. Okay, then last question E, let's see if I can fit this right here, is asking at what velocity will the rocket be traveling just as it smashes the ground? So basically we know it's going to smash into the ground after 8 seconds. So we can say t is going to be 8 seconds. So all we have to do is find v of 8, which is going to be our v function, 128 minus 32 times 8. V of 8 gives us negative 128 feet per second, which makes sense because the rocket is going to be coming down, so it's going to have a negative velocity. By the time it hits the ground, smashes into the ground, it's going to be going 128 feet per second in the negative direction. So I hope this helps you work through the prep quiz. I think these problems are kind of fun and somewhat useful.